Alright, so let's look at another category, another type of partial fractions where the denominator has some little bit of quadratic factors, especially those that cannot be factorized. Alright, so if you look at this example here, we have a linear factor x minus 1 and a quadratic factor x squared plus 1, and we cannot factorize this whatsoever because it has complex roots. So let me go ahead and do this. So I have 3x plus 1 divided by x minus 1 times x squared plus 1. So just like we've done before, since this is a linear factor, I'll go ahead and write that as a divided by x minus 1 plus, now what am I going to write for this? As you can see, the denominator, if I were to expand all this denominator here, I would have a polynomial with degree 3. So that means I must have 3 unknowns here. So what I'm going to do for this is to write bx plus c, a polynomial of degree 1, which is less than this, x squared plus 1. Alright, so we have 3 unknowns to find, and we have a polynomial of degree 3 in the denominator, so that matches perfectly. Okay, let's go ahead and do this. So I have 3x plus 1 divided by x minus 1 x squared plus 1 being equivalent to, so the LCM here, so the LCM is x minus 1 x squared plus 1. So I'm going to have here a into x squared plus 1 plus bx plus c. I'm going to multiply this by x minus 1. Alright, so the denominators cancel and we remain with 3x plus 1 being equivalent to a into x squared plus 1, right, plus bx plus c, all this multiplied by x minus 1. Alright, so what values of x would you choose here? Let's choose a nice value of x like 1, because that's going to make all this 0. So if I choose that, then I'll have 3 plus 1 equals, okay, let's put 1 here. That gives us 2a. I guess that's it. And this is going to be 0. So we'll have 4 equals 2a. And finally, a will be a 2. So that's the first value. Alright, let's go ahead and choose another value. Let's put x equals to 0, because that's going to make this coefficient to be 0, the b. Alright, so in that case we have 1 equals, so what do we have here? That's just a plus, so the whole of this is 0. I only have c into negative 1. Yeah, so 1 equals a minus c. Alright, but I know what a is, so 1 equals 2 minus c. And so I know that c is going to be, what do I do to get c? Bring c here, put 1 the other side. So c is going to be equal to 1. Alright, let's go ahead and find the last one, which is b. Now I'm going to choose any value of x of my choice, because I don't have any other value of x that will make these things 0. So I'll just choose x, maybe 2. When I put it on the left hand side here, I'll have 7 equals, okay, so I put 2 here, that's 2 squared, 4 plus 1, that's 5a plus, alright, let's put 2 here, that's going to be 2b plus c, all this multiplied by 1. Alright, so I'll plug in the values of a and b here, a and c, I guess, yeah, right, so this is actually going to be a c, am I right? Yeah, 2b plus c. Okay, so I have 5a. What's that? That's 5 times 2. That's going to be a 10 plus 2b. Oh, sorry, I've got to put there the value of b, which I don't know anyway. Minus, or not minus, plus c. C is 1. So 10 plus 1, that's 11. So 7 minus 11. What do we get in that case? Negative 4 equals 2b. And so b is going to be equal to negative 2. Alright, so I can now write my partial fraction very well. I think I can actually write this here. Okay, let me just choose red color here. So my value of a is 2 divided by x minus 1 plus the value of b is negative 2x, of course, plus c, which is 1, all this divided by x squared plus 1. So this is our partial fraction in this case. So thanks for watching this video. Please subscribe to the channel for more interesting videos. In the next video, I'll take on another example of the same category.